Just a moment now. Yeah, integration by parts. That means part by part we will learn, like when we are having two functions together in terms of u into v or in terms of f of x into g of x, then how we will be doing integration of those functions. That's what we are going to learn today. I'll be discussing first the formula with you, and then we will see some question how to apply the formula in the question. So let me take the formula first. Therefore, the formula says that integration of f of x into g of x dx can be done as, if we are having two functions, don't worry, I'll be taking the question and then it will get more clear. Let me write the formula first. So it says the first function, integration of second function, minus integration. Now here we will be taking the derivative of the first function, that is f dash x. I am going to write, please don't get confused, it is just the derivative of the first function into integration of the second function, and the whole functions, everything's now integration. Okay, this is what the formula says. Again and again I'll be writing the formula so that you can just get used to the formula. This is what the integration by part rule says, that when we are having product of two functions, this is how we can do the integration. Okay, here if I'm taking one question as one very simple example, as let's say I am going to take integration of x cos x dx. Then according to the above rule, we can do the integration directly by using the given formula. The formula says first select which function is the first function, which function is the second function. You can take this one as a first function and this one as a second function. You must be thinking that we can also take this one as a first and this one as a second, because x into cos x can be written as cos x times x. It can be written. So first function, second function, how we will decide that just after a while we are going to discuss it. But let's see how to apply the formula first. Okay. So first function, second function, till now whatever I am saying, just take it as it is. And just after a while we will be discussing how we are going to choose which one is the first function and which one is the second function, because 3 into 4 can be written as 4 into 3. And we can take any one of them as a first, other one as a second. Okay, so that we are going to discuss just after a while. So here the formula says that first function, that is f of x, as it is we have to write. Now integration of second function, so integration of cos x. Now according to the formula, we have to take the derivative of the first function. So d by dx, if you will be taking x, what you will be getting? Derivative of x is what? Anyone?
1.
So we are taking derivative of the first function. F dash x, here it is written. So instead of f dash x is what? Just the derivative into, again, integration of the second function dx, and whatever we are getting the complete result, everything's integration. Let's do it. First function cos x, integration is, what is the integration of cos x?
Minus sin x. Sorry, sin x integration.
Yes, cos x is sin x. So Sin x only will be taking, minus here derivative of x is 1 as you said, and integration of cos x is only sin x. Everything's integration at last we have to do. Here we got x sin x minus, here we are having only sin x integration. Only sin x integration will be what? Anyone?
Minus cos x.
So we got minus cos x. That means we got constant of integration also. That means we got x sin x plus cos x plus c. This is how we will be doing the, just a moment now. Yeah, this is how we will be doing the integration by parts. According to the rule, we have just each and every step we have written according to the given formula. Now here you must be thinking, the question was how to select the first function and second function. So whenever you are having x like this with any function, please take it as a first function. Why? Because its derivative will be 1 here. And eventually it will give you a very simple integration for the second part. So let's do few more questions like this. So the next question can be, suppose we have to do, we will be coming to log x. Let's see. Let's do a simple question. That is x e to the power x dx. Again, integration by parts rule. What the integration by parts rule says, that whenever we are having f of x into g of x, that's integration. If we have to do, we'll be taking first function, integration of second function, minus first function's derivative, that is f dash x, and second function's integration, and whatever result we are getting in total, that's integration we have to do. This is the formula, and this formula now we are going to apply in our question now. So let's apply the formula. So it says first function, as I said to you, how you will decide which one is first function, which one is second function. So whenever you are having x, you know that derivative of x is 1, and here if we will take f of x as a like a first function, that is f of x, if you are taking as a x, then f dash x will become 1, and that will help us to simplify this integration. So let's do it. It says first function, that is x, integration of second function, that is e to the power x dx, minus derivative of first function, derivative of x is 1, I am going to write directly, into integration of second function, that is integration of e to the power x dx we have to find, and whatever result in total we are getting, that's integration we have to do again. Let's do it. X e to the power x, integration is e to the power x, minus here 1 is 1 only, and e to the power x integration became only e to the power x, and this complete functions integration now we have to do, that is e to the power x dx, that is only e to the power x, and here x e to the power x. Are you getting how we are using the formula? Everyone?
Yes, ma'am. Yes, ma'am.
So this is called integration by parts. Similarly, let's take one few, like a very basic question, x sin x if we are having dx. Just like cos x, we can do it. Again, if you want to write the formula, if you want to get used to the formula, let me write it again. So whenever we are having fx, into gx, and that's integration we have to do. Then we will be taking first function, integration of second function, minus derivative of first function into integration of second one, and total integration. This is the formula. Why I am writing it again and again? So that it will just get register in your mind, and you will start using it very quickly just by looking at the question. Okay, it will be first function x, integration of sin x. What is integration of sin x?
Minus cos x.
Minus cos x. Let's write it quickly without writing even gx and all. Minus derivative of x will be 1. Integration of sin x, now only you said it's minus cos x. The whole thing's integration. So whole thing, if I'll focus on whole thing in this bracket, I can see minus can come out, and it is only cos x dx. And the beginning one, the starting one, it is minus x cos x. Okay. Now minus x cos x, and integration of cos x is sin x plus constant of integration. So this is how quickly we are going to apply the rule. Is it clear?
Yes, ma'am.
Yes, ma'am.
Now, if we are having log x, let's say we are having log x. And for now, it's written in the question that use the formula of integration by parts and do the integration. Now you must be thinking that here only one function is there, that is log x is there. Logarithmic function is there. So how we are going to take two function fx gx? So yes, we can take two function over here. One is log x and another I'm going to take as a 1. Okay, dx. Now which one is the first function, which one is the second function? Let's do it, and then I am going to show you why we are going to choose whatever we will be choosing as a first function. So I am going to choose this one as a first function and this one as a second function. What is the second function and first function? Second function and first function means fx gx, the rule which we are applying. You can see both we are treating it differently. F of x, what we are doing? Eventually in later part we are doing derivative of that. So that's what the difference between fx gx. So I am going to take this one as a fx and this one as a gx. Let's see how it's working over here. So the formula is, do I need to write the formula again? Or it's already, you have understood the formula? Let me write one.
Understood, ma'am.
Okay, you know the formula. So the formula says first function, that is log x, integration of second function, that is 1 dx or only dx, is the same thing, minus derivative of first function. We have to find derivative of log x. Okay, and then integration of the second function, and that's total integration again we have to do. This is what the formula says. So log x dx will be, anyone? Dx will be only x, right?
Yes,
If
ma'am.
only x I am writing, minus derivative of log x is 1 by x, right? And
Yes, ma'am.
in dx will be only x. X cancelled out, dx we got. So we got x log x minus dx is there. That means only x plus c. Now you must have understood why we have taken log x as a first function, so that we will be doing the derivative of it and it will simplify something. So whenever you are having log x, please take it as a first function, so that later on we will be doing derivative of it and it will simplify few things in our integration. Let's take one question from the exercise now. So the first question is from the exercises, x sine x. We have already done that. The next one is x sine 3x. The way we have taken x sine x, similarly we will be doing x sine 3x. By 3 will be coming, into 3 will be coming. That's totally fine. Okay. Now the next one we are having x square e to the power x. So if we are having x square e to the power x, let's do it. First function, second function. Whenever x square, this type of function is there, we'll be trying taking it as a first function. So the formula says first function integration of second function minus first function's derivative d dx of first function we have to find. Okay, and integration of second function we have to find, and in total we have to do the integration. This is what the rule says. Let's do it quickly. X square e to the power x dx will be e to the power x only, minus derivative of x square will be 2x, and e to the power x will be e to the power x only dx. Is it clear so far to everybody?
Yes, ma'am.
So we are having x square e to the power x minus 2 will be coming out, and we are having x e to the power x dx. Now what is this? Is it very simple integration? Is there any formula for x e to the power x? No, there is no formula for x e to the power x. So what should be done? Again, we have to do the integration of this one by parts. Okay, how? Just like this one. Just like this one. Can you see it? X e to the power x integration, what we have got? Parts. Let's do it again. So while doing integration by part, again we came in the loop that one function came out in such a way that again there also we have to apply integration by parts. Okay, so let's do it, no worries. Here we are having this integration, I am writing it as I. Okay, 2I, and this one I am writing as it is. Now I, we have to do it. I means what? I means x e to the power x dx. Let's do it quickly. First function, integration of second function, minus derivative of first function, so d dx of x, and integration of second function, and complete whatever we are getting completely, that's integration we have to do. So we got x e to the power x minus derivative of x will be 1. 1 into e to the power x integration will be e to the power x only, and completely we have to do the integration again. So be careful, here we are doing integration 2 times. X e to the power x minus, this is just e to the power x dx, that is e to the power x only. So can you see our integration result? I result. Let's substitute it in equation number 1. So result of I, here only I am going to write. You have to write it below. Okay, just for your clearance, I am writing it here. X e to the power x I have got minus 2 I we were having. So I value I am going to put it over here. X e to the power x minus e to the power x plus constant of integration. Here also you need to take the constant. Okay, if you are taking C1 over here, then directly you can take C over there. That means constant plus constant together is another constant. That's it. Okay. So we ended up getting x square e to the power x minus 2x e to the power x plus 2 e to the power x plus C. Is it clear to everyone what we are doing here?
Yes, ma'am.
So what we started applying by parts formula, integration by parts formula. But once we applied the formula, we found that again we got one integration where we need to apply integration by parts formula. So separately we have done that, and we have just gone back and applied just substituted the value over there. Let's move to the next question. So the next question is x log x. I said to you, whenever you are saying x log x, with logarithm you are saying, so please take this logarithm as a first function. Okay, if this integration you have to do, then please assume it that you have to do this integration, log x into x dx. Because multiplication is there, so you can write it here and there. Multiplication is commutative. 3 into 4, 4 into 3 is the same thing. Okay, so I'm just writing it here and there, and now I'm going to apply the formula. That is first function, integration of second function, minus derivative of first function, integration of second function, and completely integration. So we got log x. What is the integration of x? Quickly, please tell me. Integration of x is what?
1, ma'am.
Integration. X to the power n
Sorry,
का?
x to the power 2 by 2.
Exactly. So
Yes.
x square by 2 minus derivative of log x means 1 by x, and integration of x will be x square by 2. Completely we have to do the integration. Is it clear so far to everybody?
Yes, ma'am.
Yes, ma'am.
And that's how this x and one of the x from here will cancel out each other. And that's why I told you to take logarithm of x as a first function, so that after doing derivative it will be 1 by x. Okay, and it will simplify something. You can see it is simplifying, which is making the other integration very easy. That is x by 2 only we got here. That is 1 by 2 I will take it out, and x dx I will be doing in the next step. And again I'll be getting 1 by 2 x square by 2 only. That is x square by 4. And the first part we will be copy pasting as it is. So x square by 2 log x. X square by 2 log x. Again x square by 2 log x. X square over 2 log x minus x square by 4 plus constant of integration. Is it clear?
Yes, ma'am.
So whenever you see x with sin x, x with cos x, you have to take x as a first function. Okay? Whenever you are having any trigonometric function, sin x, cos x, tan x, cot x, cosec x, whatever you are having, please take x as a first function, so that after doing derivative, it will become 1. But whenever you are having logarithm of x with whatever, please take log x as a first function. Okay? Let's do the next question. Now the next one I can see x into log x, log 2x is there. X into log 2x is there, and that's integration we have to find. You know, this is the first function. This is the second function. And if you are getting confused while writing this one, you are not able to apply the formula properly, you can change it. You can write log 2x at first, and then you can write x, and then you can go ahead and you can do the integration of this one. Okay, let's do the, let me take one question from here. So if we are having, the next one is also x square log x. I said to you, take log x as a first function, x square as a second function. So if you are having x square log x, this is our first function and this is our second function. Accordingly, we will be using the formula. What about this one? If we are having x sine inverse x with normal trigonometric function, I told you when x is there, take that as a first function. But with inverse function, what to do? So let's do it first. Then I'll be showing you why we are going to take the sine inverse x as a first function. So I'm going to take this one as a first and this one as a second. So let me write it that way only, so that you will not get confused. This way I'm going to take the given question. Okay. Now the formula is first function, integration of the second function, minus derivative of first function. What is the derivative of sine inverse x? D dx of sine inverse x. If you are having formula written anywhere, please do check and tell me what is
1 upon under root 1
the
minus x
formula
square.
for, so that
1
anybody who has forgotten the formula, they will be able to. Just a moment. Just a moment. Let me share it again. Can you see the screen?
Yes, ma'am.
So yes, please tell me what is the derivative of sine inverse x?
1 upon under root 1 minus x square.
1 by under root 1 minus, okay. Have you said minus 1? It's 1 by under root
No.
1 minus x square, right?
Yes, ma'am.
And this x dx will be x square by 2. And completely we have to do the integration again. That is about the second part. What about the first part? So sine inverse x was the first function which I have written as it is, and dx will be, okay, was it dx? It was x dx. So this will be x square by 2. Is it clear so far to everyone?
Yes, ma'am.
Now let's think about what can be done in the second integration part, because first one we are sorted. Sine inverse x into x square by 2. This one is done. What about the next part? That only we have to figure it out now. Okay. So I'm going to copy paste this one as it is. X square by 2 sine inverse x as it is. Now the next one is, we are having 1 by 2. If I'll be taking it out, we are having integration of x square by under root 1 minus x square dx. Now this looks something which we have to do the arrangement. Let's see if any arrangement will work over here or not. Okay. So in denominator, as I can see, under root 1 minus x square. In numerator also, I am trying to make under root 1 minus x square. And if you are not sure here, you can take it separately and you can do the integration. Okay. So I want to say that in denominator 1 minus x square is there. In numerator also, I need to I'm trying to make 1 minus x square. If that is working, well and good. If that is not working, we have to think about the other approach. Okay, let's see whether that is working or not. So we will be having 1 minus, first let's make it minus x square to avoid the confusion. So minus outside I have written, and inside also I am writing x square. Okay, why? Because in denominator there is 1 minus x square. So in numerator also I am trying to make minus x square. If directly I'll be writing 1 minus x square, it will be get clear to few student, and few student will end up getting confused. So that's why at first I am making it minus x square. Now I am going to make it 1 minus x square. So minus outside, here I am adding 1 and subtracting 1. So minus x square I have already made. I will be adding 1 and subtracting 1 by under root 1 minus x square dx. Now I am going to separate it. So I want to write it as minus outside, let's keep it 1 minus x square divided by under root 1 minus x square and minus 1 by under root 1 minus x square. Total together dx. Are you getting it what I am doing here? Everyone?
Yes, ma'am.
We are just doing a slight arrangement. Why? Because I can see x square in the numerator. Okay? And I can see x square in the denominator also. So I want to make numerator just like the denominator. How can we do that? By adding 1, subtracting 1. But we also have to be careful with the sign. So that's why at first I made it minus x square by taking 2 negative sign, which eventually is negative, negative, positive. And then I made it like this. Now, why I'm making it like this? So that this became, let's keep minus outside. This became integration of, like if you are having 3 by root 3, can I write it as root 3 only? Can I
Yes,
write?
ma'am.
3 means what? Like if you know the concept of rationalization, you know that root 3 can be multiplied over here, root 3 can be multiplied over here. This became 3 root 3 in the numerator and only 3 in the denominator. This 3 gone and we got only root 3. Okay, so either by the concept of rationalization, or if you understand that 3 means what, root 3 into root 3 only, and by root 3 is there, so only root 3 is the remaining. Okay, so I am going to write the same over here, that 1 minus x square by root of 1 minus x square will be only root of 1 minus x square. I'm going to write here only root of 1 minus x square. Please stop me if this step is not clear to anyone. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay. So now this is the first integration we are having, and second one, let's write it as it is 1 minus x square dx. Let's go ahead and let's continue. Are we having any formula for the first one and for the second one? Anyone? Have you done those formulas? Let me check. Was it there in the very beginning in the book or not? Before doing this integration, have you learned the formula of 1 by under root x square minus a square is having one formula? Let me write. Dx by under root a square minus x square is equals to sine inverse x by a plus c. Have you seen this formula anywhere? Have you seen this formula?
Yes, yes, ma'am.
Yes or no?
Yes, ma'am.
Yes, and one more formula I'm going to write, that is for under root a square minus x square. Let me check those also, whether you have done before this exercise or like it's after this exercise or what. So if we are having integration of under root a square minus x square, yeah, there is a formula for that, that is x by 2 under root a square minus x square plus 1 by 2 sine inverse x. Let me check whether this is the formula or what. Actually, there is a process to do this integration, but without process, we can directly use the formula also. I am checking whether you are having those formula. If you are having those formula, then we will directly be writing the result over here. Okay. Okay, let me check whether let's use the proper method, which is saying that 1 minus x square can be written as under root. Let's say we are taking minus of, we are trying to make it a square formula, but eventually it will land us to something else. So if we are taking x as a trigonometric substitution, sine x, so it will be dx will be cos x cos theta d theta. So 1 minus x square, if we will do by trigonometric substitution, it will be 1 minus sine square theta, and dx will be cos theta d theta. 1 minus sine square theta is cos theta into cos theta d theta. So basically we got cos square theta d theta, which can be converted into the rule of, don't worry about this integration, I am telling you the result directly. So cos 2 theta rule is 2 cos square theta minus 1. So cos 2 theta plus 1 by 2. Cos 2 theta plus 1 by 2 we are taking over here, and then we can take sine 2 theta as a like integration of 1 by 2 cos 2 theta plus 1 d theta. Cos 2 theta integration will be sine 2 theta divided by 2, and 1 will be only theta. Now let's, if we will do substitution, back substitution, so it will be theta will be sine inverse x. So 1 by 2 sine 2 theta, we need to write it 2 sine theta cos theta by 2 plus sine inverse x, and it will come out as a 1 by 2 2 sine theta was x, and cos theta is, if x is sine theta, then we know 1 minus sine square theta is cos square theta, and cos theta is under root 1 minus sine square theta, that means 1 minus x square, under root 1 minus x square by cos x. Okay, 2 and 2 will cancel out each other, and we are having 1 by 2 x under root 1 minus x square plus sine inverse x. Actually, I was not getting this formula in your book, and was how to just reach the formula, that I can do, but the formula, since it's not given, so I was not able to take the formula directly. But this is the formula. If we are having, like in terms of under root a square minus x square dx, we are having the formula is x under root a square minus x square plus sine inverse x by a. This is the formula. Can you see it? Can you
Yes,
see
ma'am.
this?
Yes, ma'am.
Is it known to you? Is it known to you? Because in your book in NCRT, in my NCRT, I can't see this formula. In your NCRT, is it there? We will be just getting this formula by trigonometric substitution, but we don't say student to go and just do this much of calculation. There is a specific formula which we need to apply it directly. Okay. So
Yes,
the
ma'am.
rectangular box one we are going to apply directly, and this one also we are going to apply directly. Okay. The first, this one is there in your book, I can see. That is dx by under root a square minus x square is sine inverse x by a plus c. This formula is there. However, I was not getting this formula in your book. That's why this much of calculation I needed to do. So let's put the values. Okay, the green one. Can you see it over here? The green one and the other green one. I am going to put the values over here. So we will be having, we are having in the green boxes minus under root 1 minus x square dx. This was our first integration, and the second integration was minus dx by under root 1 minus x square. Okay, Both the formula I have written over here. The first formula says sine inverse x by a plus c. So this formula says sine inverse x by a. A is 1 plus c. Okay, so I'm writing it this much only. Is it okay to everyone? This is what the
Yes, ma'am.
formula is. And now the second formula we reach at this one, 1 by 2. So this one says 1 by 2 x under root whatever is there, just copy paste it, x square minus a square, or like a square minus x square, and then plus here also we are having sine inverse x by a. So it will be sine inverse x, a is 1, so by 1, this is the total expression we are having. Is it clear to you? And yeah, one more thing we have to be careful here, 1 by 2 is outside. So this is for this term also, and this is for sine inverse x by a also. Let's write it properly. Okay. So is it clear, the integration part? Both the formula directly you need to apply. This much calculation, please don't see it. Because here I have done a trigonometric substitution which you don't need to do. Okay. Is it clear?
Yes, ma'am.
Now let's continue. So here we ended up getting minus 1 by 2 x under root 1 minus x square. 1 by 2 plus 1 will be 3 by 2 sine inverse x. And this is what the total integration we got from this blue part, from this second part. The first part is still there, that is x square by 2 sine inverse x, and minus 1 by 2 is also there in the beginning, like in front of that. So we have to just combine everything now. So let's see the question from the very beginning. What was the question? The question was x sine inverse x. Okay, here we needed to choose which one is the first function and which one is the second function. So we decided that sine inverse x will be the first function and x will be the second function. Why? Because we know the integration, like we know the differentiation of sine inverse x, right? But do you know integration of sine inverse x? Do you know?
1 upon under root 1 minus x square.
Yeah, that is the derivative of sine inverse x, no?
अच्छा.
Yeah.
Oh.
So integration formula, if we will see from here, if all the integration formula which is given in the very beginning, if you will see the formula, this chapter here, if you will see all the formula here, sine inverse x formula, is it there? No, it's not there. Can you see? Like you must be having in your book also. You can open the page and you can see derivative is given on one side of sine inverse, tan inverse, everything, but integration of sine tan inverse is not given. Yes or no?
Yes, ma'am.
Yes, ma'am.
That's why we have chosen this sine inverse x as a first function, so that we will get the opportunity to do the derivative of this one. Okay, so we have just taken sine inverse x as a first function, x as a second function, and we have applied the formula. Once we have applied the formula, the first part was very simple, but the second part became quite tricky, quite difficult. It became sine inverse x derivative, which we have applied the formula 1 by root 1 minus x square, and other one is x dx, that x square by 2 we have done the integration. Now we ended up having this total red part. In this red part, this integration x square by root 1 minus x square was quite like we needed to arrange something over here. So this is the difficult part, which we have done separately. When we have done this separately, what we have done here, we have whatever is the denominator inside the root, we have tried making the numerator just like that. And once we have made the numerator just like that, we got two integration, and both are having the formula. Okay, the first one is having the formula, that is, if we are having under root a square minus x square integration, the formula is this one. if we are having under root a square minus x square integration, the formula is this one, 1 by 2 in bracket x under root a square minus x square plus sine inverse x by a. And the other formula which we have applied here is this one. If we are having dx by under root a square minus x square, which you have done, this formula is known to you. I can see in the chapter itself here, when you have used some properties, integral of some particular function. You have done that, right? Integral of some particular function. So here I can see this formula, which is already given in the book itself. These are the formulas. Can you see it?
Yes, ma'am.
It may be looking reverse way because we are on the camera, but these are the formulas. Here we are having 1 by under root a square minus x square. Formula is sine inverse x by a plus c. That I have taken and put it over here. Okay. And that's how we got the final result. So is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
To the next question. Similarly, if we are having x tan inverse x, x cos inverse x, always we will be taking the inverse function as a first function, because we know how to do the derivative of tan inverse x. We know how to do the derivative of cos inverse x. So always whenever inverse function is there, please take those inverse function as a first function. Okay. Now let me pick one question from here, the difficult one, which we will be discussing. Okay, so if we are taking this question, if we are having integration of x cos inverse x by 1 minus x square dx. This is the integration we are having. Here also we have to do it by parts. How many functions are there? I can see a lot of different functions are there. X is there, cos inverse x is there, by 1 minus under root 1 under root 1 minus x square is there. So different terms I can see over. Which one to take as a first function, which one to take as a second function, that is the confusion. Okay. So here we will be doing substitution. From day one, I'm asking you whether you know the concept of substitution or not. It is like, was it in class 11 integration was not there, right? Or it was there? Huh?
No, it's not there, ma'am. Not in maths.
It was not there in maths. So you started doing integration from class 12, right?
Yes, ma'am.
So there, have you learned the concept of substitution?
Yes, ma'am.
You have learned, no? Like
Yes,
how to
ma'am.
do the substitution. Okay, so
Yes,
why
ma'am.
I'm just getting worried that much? You are already having the concept of substitution. Previously also I was doing the trigonometric substitution when I was finding the formula. Here also we need to do one substitution. This is what we have to do it. So here, what is the derivative of cos inverse x? Anyone? Derivative of cos inverse x?
1 upon minus under root 1 minus x square.
D dx of cos inverse x is equals to minus 1 by under root 1 minus x square. Is it so?
Yes, ma'am.
Okay. So now can you see one cos inverse x is there in the numerator, and something what you said, just like that a term is sitting in the denominator. Can you see? So let's do the substitution over here so that the denominator and numerator will get simplified, will get absorbed with each other. So if I'm going to consider from the question, this was just the formula. Okay, we will be using this formula just after a while. So I am going to consider cos inverse x as a t. Okay. Now what we do, whenever we do the substitution, we have to do the derivative of both sides. Why? Because this dx also I want to convert in terms of dt. Then only I can go ahead and can do the integration. So cos inverse x, if I am assuming as a t, it will be 1 divided by under root minus 1 rather, divided by under root 1 minus x square dx is equals to dt. Is this step is clear to everybody?
Yes, ma'am.
Here I have done differentiating both sides. And that's how we landed up over here. Okay. So we are already having 1 by 1 minus x square. So I am going to write dx by under root 1 minus x square can be written as minus dt, right? Now let's do the substitution. X also we need to change in terms of t. That we will be changing. Just I'm showing you for this step, but please don't write like this. We need to write everything over here in terms of t. We will be writing it just after a while. Cos inverse x I have taken as a t. Dx this much. This much dx by under root 1 minus x square is minus dt. So can I write directly minus dt by taking the complete dx by under root minus 1 minus x square? 1 minus x square. Can I write it directly dt minus dt? The circle part?
Yes, ma'am.
Yes, ma'am.
Let's write it. Yeah. So I am going to write minus dt. Whether there is any denominator? No, there is no denominator. We are almost sorted, but we are having x over here. That also we need to write in terms of t. So we have assumed that cos inverse x is equals to t. This is what we have assumed, that cos inverse x is equals to t. So can I say x will be cos t?
Yes,
Can I
ma'am.
say? Let's write it. X is cos t. From where we are writing that? From our substitution only. So let's write it. So here x is cos t. T is only t minus dt. What we got? Minus t cos t dt. Can you see it can be very easily done by the method of like integration by parts? T cos t. How? Let me show you how. Just like this, x cos x, the way we have done. Can you see x cos x?
Yes, ma'am.
Similarly, can we do t cos t?
Yes, ma'am.
Let's do it quickly. So the formula says, if we are having t cos t, the formula says minus, keep it aside. First function, which one is the first function? T or cos t? Anyone?
T, ma'am.
T is the first function because when we will be doing the derivative of that, that result will be 1. And whenever we are having trigonometric function like this type, not inverse trigonometric, if we are having normal trigonometric function, sin t, cos t, tan t, cosec t, we will always be taking those as a second function and x as a first function. So here t as a first function, derivative integration of cos t dt minus derivative of t will be 1 and integration of cos t and whole integration we have to do. So we'll be having minus t, cos t will be sin t, right? Minus cos t will be sin t. And again, we have to do integration of that. So let's do it. So we will be having minus t sine t minus sine t integration will be negative cos t, right?
Yes, ma'am.
Yes or no? Sin x का इंटीग्रेशन क्या होता है?
minus cos x.
So let's write minus cos t plus c. There is no difference in between x and t. Okay. Instead of x, it can be y in any of the question. So it's just the variable minus t sine t plus cos t plus c. This is what we got. If we will open the bracket, everything will get negative, negative, negative. Now we have done the substitution. We have done the substitution is equals to t. Now we have to do the back substitution. So wherever you are seeing t, please write it as a cos inverse x. And then and only then we are done with this integration. So back substitution we have to do at last. So here t is there, I'll be writing cos inverse x. Sin t is there, no worry. Sine of cos inverse x, I have to write it. Even if it looks so weird, but it has to be there. Okay, cos t, that means cos of cos inverse x plus c. Okay, outside minus is there. Cos of cos inverse will be only x, so we will be having only x over here. So we'll be having cos inverse x. Sine of cos inverse x, we can't solve it, let's write it as it is, plus cos of cos inverse x will be only x plus c. You know that cos of cos inverse x is, if we are having cos of cos inverse x, it will be only x. This will cancel out each other. You know that, right? Actually, in general, according to the concept, it is not canceling out each other. Okay, just with the help of inverse function, we are using this like x we are taking, but it is not canceling out each other. Again, we are thinking about a substitution, that cos inverse x is this one, then cos x will be only x. So do you know this result or not, everyone?
Yes, ma'am.
That's why I have taken only x over here. Basically, in according to the concept, it is not canceling out each other. By substitution, we will just get back to x only. Okay, so this is how we will be doing this integration. Let's summarize it. So we were having x cos inverse x by under root 1 minus x square, and we were thinking how to do this, but we got to realize, like we realized that cos inverse x, we can see here, by 1 minus x square, under root 1 minus x square is also visible. So if anything like this is visible in the integration, that one is the derivative, another is the actual function, then we always do the substitution at first, without even thinking about by parts will be there, or some particular formula will be there, or any other method will be there. First, whenever you see that one function is there and that function's derivative is also sitting in the given integration, so first go and do the substitution. Okay, so here we have done the substitution of cos inverse x as a t, and we got 1 by 1 minus x square dt. Everything we got, once we have arranged everything, we ended up getting t cos t. Now, just by looking at this t cos t, anyone can say by parts. It can be done easily by integration by parts. So we have applied the concept of integration by parts and we are done with it. Okay. Is it clear?
Yes, ma'am.
Let's do one
Yes,
more.
ma'am.
Okay. Today you are going to give, no, not today, because it will take one more class to finish everything. Okay. So yeah, the first, at least first 15 question you will be able to do by yourself. So that will be your homework. an assessment you will be able to give in the next class. So I am taking the last question, today's last question as x sec square x dx. Now it's our responsibility to understand which one will be the first function, which one will be the second function. I told you whenever we are having x with sin x, x with cos x, x with tan x, x with sec x, x with cosec x, always take x as a first function. Okay. So let's see whether x as a first function is helping us over here or not. So if we are taking first function, integration of second function. Do we have any formula of this one, sec square x integration? Do we have?
Tan x plus tan x plus c.
Yeah. Sec square x integration is tan x only, right? Right?
Yes, ma'am.
Yeah. So let's continue. Minus derivative of first function, d dx of x, and integration of sec square x dx, total integration. Now sec square x integration is tan x. Everyone knows that the integration of sec square x is tan x plus c. Yeah, c will be, we will be taking c at last. So integration of sec square x is tan x. Everyone knows that.
Yes, ma'am.
Minus derivative of x will be 1. Sec square x means tan x and dx. So here we are having x tan x minus tan x dx. Yes or no? What is the integration of tan x? What is the integration of tan x? Anyone? Log of?
Ma'am, it doesn't have.
It
Ma'am,
doesn't.
log of sec x.
Exactly. So it's log of mod sec x. X
Yeah,
tan x.
mod sec
Let me
x.
check in your book as well whether it's given or not. Log of mod sec x plus c. Okay. This is the formula for this one. Let me check in your book whether the formula directly is given over here or not. So I am keeping it this much. So in which chapter you have learned this? Yeah, whoever I've answered that integration of tan x will be this one. Yes, in which chapter it is there? Actually, it came out from the concept of substitution only. I can't see it for now in the book itself, but it actually came out from the concept of substitution. That if we are having tan x dx, we can write it as basically we can write it as sin x by cos x dx, right? Now here you can see, if you will put this, you will get it. So cos x, if we are putting as a t, so derivative of differentiating both sides, cos x derivative will be minus sin x. Yes or no?
Yes, ma'am.
Yes or no?
Yes, ma'am.
So sin x dx will be minus dt. Let's write it. So minus dt by t. And from here only it came out as a minus out log of t plus c. And log of t will be log of, okay, it came out as a log minus log of cos x plus c. But we have taken log of sec x. So this minus power, the logarithm function says whenever we are having m log n, this can be written as log n to the power m. Yes or no? Do you know this logarithm function property?
Yes, ma'am.
So this minus 1 which is there in front of the log, I am going to take it as a power. So this came out as a cos to the power minus 1. Please don't assume it as a cos inverse. This is not inverse function. This minus 1 in the front came out as a power. Okay. That will be log of 1 by cos x. And that only came out as a log of mod sec x. Okay. This is the formula. You just memorize the formula. This much step you don't have to do it. कि tan x का integration होता है log of mod sec x. That's it. This is how we just get it by doing the substitution only. So here in this exercise, integration by parts, you will be able to do questions from 1 to 15. Now please ask your doubt, whatever we have discussed, anywhere if you felt that this is not clear.